All right. This is Mike Ramos. I'm our federal program manager here at Raymond and also executive vice president. I appreciate everybody joining our Lunch and Learn session today. I hope you find it very informative. Ray Ramos, our founder and CEO, is going to be speaking on anatomy of a building envelope failure. As you're joining, I've already muted all of our participants here today. So if you do have a question, we'll just ask that you submit it through the chat function, and I will periodically be reviewing that and also bring it to Ray's attention. So if you have any questions, you can also message me directly if you prefer, and we'll make sure that those get addressed. But I'm going to turn it over to Ray Ramos, and Ray, you can take it from here.
Good afternoon, everybody. Glad you could join us for our Bring Your Own Lunch and Learn seminar that we've been doing periodically with everybody kind of unable to come to the office on a regular basis, although if you're essential, I guess you are coming to the office on a regular basis. But won't get into a lot of marketing details. I'll leave that up to the BD folks whenever they get a chance to talk to you later on. Anyway, what we're going to cover today, we have a number of presentations that we do, either face-to-face or lately we've been doing them through Teams or through Zoom. And this is one that was developed by Dave Willers in our Raleigh office, and I've gone and taken it and use it on occasion and give this presentation. Essentially, if you are a registered architect, you will get, you can get AIA for this particular presentation. If you will have some other certification, a PE license, whatever the case may be, make sure that you indicate that you will need a PDH, and Jessica will get that certification to you, that certificate to you. So what we will cover in this presentation essentially is issues that you can encounter with a building envelope failure. And we call it building envelope now because primarily a lot of people years ago when I got in the business in '84, you know, we were really paying most of our attention was to the roofs. We would look at the walls, structures, but for the most part, everybody was paying attention where the water is coming in through the roof system. With the changes in how we now build the facades, more and more we're finding that maybe the roof isn't always the problem. Maybe it's something else with the structure, with the building envelope components that are causing the water infiltration. And with the emphasis on air barriers, it has definitely had an impact upon condensation issues that can occur within a facility over mostly long periods of time. So we'll take a look at what can entail in a building envelope failure. We're using in this particular presentation a project that was actually one that we did over in Eastern North Carolina a number of years ago. How the methodologies used in order to determine what the problems were and the solutions that were developed in order to solve these particular problems. So what we're going to look at is we're going to look at a neurology clinic in Greenville, North Carolina. When you look down on it, it looks like a pretty standard building. You can see we have a flat roof area. We'll zoom in closer and you'll be able to see that we have metal roofs on most of the building. And when we look closer, we have a brick veneer facade. And this kind of gives you a layout of how the building is presently being used, where we have the entrance and office wings, we have exam rooms, they have an MRI area near the center of one of the wings, and then physical therapy. Not much different from any time that any of us have been in to see a doctor or a specialist. And so looking down in it on the floor plan, you see it's really just broken down in mostly an office configuration. Even the MRI, CT areas are office layouts, except now they have specialty equipment within those. Physical therapy will have basically weights and equipment that's going to deal with these particular patients. When you look inside, you can see, again, it's a typical medical office facility, sheetrock walls, lighting in the ceilings, drop ceilings, pretty standard carpeting in the flooring areas, and linoleum for the most part. Now, the owner is basically complaining about water coming in the building. That's really what they're dealing with. And as a result, they've got peeling paper, they have mold as some of the issues. Now, they're really not certain what is the cause of it. They suspect the roof as being the problem with this particular infiltration problem. So, you know, we're to go in and look at this and see what is the problem. Is it the roof? Is it something else? Is it windows? Because a lot of the leaks are around windows. And so typically what you're going to look at is, as you see on the left, here is a process that you would use in order to determine what the problems are. The most obvious, let's walk the building, let's look at the components of the building, where the leaks occurring, and that's just a visual inspection. If you need to do testing or more invasive type examinations, this could entail water testing, infrared work, nuclear work, whichever the case may be on the roof. It may require the removal of some sheetrock inside in order to look at some of the leaks that are occurring, particularly as you go into water testing. So those are some of the things that you get into with this. So, like I said, excuse me, I'm at the house and I didn't bother to deal with that particular phone. Anyway, as you can see from ground level, we're dealing with a brick veneer on the vertical surfaces. We have some inset brick veneer also on the 2-story and a few other locations. As you can see, we're typically dealing with a lintel system to hold up the brick above these inset areas, and then the window systems in there. The roof system, standing seam, typical systems that you have with metal. What's a little bit unique about this is we have a gutter system, and not trying to pick on architects, but you know, architects tend to not like gutters. But we have to control the flow of water, but we also, you know, they also wanted to make it blend in with the facility. And so these are actually gutter systems that sit on top of the walls, the exterior walls. So that's how they blended the gutter system in, so it doesn't really jut out from the facade. Leaks that are occurring, essentially the vast majority are at the perimeters, at windows. There are some that are in the hallways offset from the windows, but that's not typical. We've got the physical therapy area. They've got window leaks also throughout this area. And what's really interesting about these window leaks and the problems that they've been having, because they've been having them for quite some time, is the development of mold. And essentially what you're looking at here is aluminum tape. And the reason it's here is because, you know, most patients and medical folks really don't like people to see mold. They get upset about it. We need to do something. So the interim solution for the clinic was essentially, let's use the tape in order to remediate the mold, which, you know, I thought was a pretty interesting way of mold remediation. We can see at the windows where we have some deterioration of the sills, indicating that the water is coming in. We have wallpaper that's coming loose in these areas. So typical things that you would see that might indicate we've got window leaks. Again, we have tape to control mold in certain locations. So we may have a window problem here. And we can see, again, deterioration of the wallpaper to the point that we've got mold that's developed on the sheetrock at the windows. So could it be the windows? It could be. Could it be an air barrier issue? That's a possibility too. Doesn't always mean that we do, but it gives us an indicator of what the next steps are going to be. So, you know, one of the things you have to be careful about is whether or not to use wallpaper at exterior walls, particularly in the South. And usually the problem is because we have a lot of leaking that occurs through penetration such as windows. And as a result of that leakage that occurs coming in and going out, we also have the movement of vapor. And it will find a place to condense. It will be a dew point in that as it moves through that system, through that opening. And depending on the materials that are there will determine whether or not you will have some problems with wallpaper and mold and mildew developing on these particular components. So very important that, that the air barrier system is well developed just to make sure that you don't have that particular problem. Can you put wallpaper in the South on exterior walls? Yes, you can. But again, make sure you're dealing with the movement of air and moisture, particularly at penetrations. Some roof conditions, the condition of the roof appeared to be pretty good. Some minor problems, you know, you bring in a ridge flashing into a valley, which is something you really, really don't want to do. And it's difficult to flash already. So usually the solution for a roofing contractor is if I caulk it up enough, it'll solve my problem at least until the warranty expires. So they're already having failure of the caulk. Is it a leak? It all depends on what's underneath the metal system. If they've got a good secondary membrane underneath underlayment, very likely that water is shedding to the eaves and nobody would be the wiser to a problem. So we talked about the interior gutters that have been installed. And again, you know, architects like to hide things that don't look good, and downspouts don't look good either. So that in this case, on the left side, they're actually behind the veneer at the columns between the windows and at the brick. And in some cases, you also see that they actually built them inset into the wall. So technically they're not in there, but they're there to look a little prettier, you might say. They don't stick out when you do it that way. Other issues that you can encounter, particularly with brick veneers, they have a tendency of cracking. It could be a settlement issue. That's usually what this particular crack at the window indicates. We've got a little bit of settlement, but it's not terribly bad. You're going to get separation on a normal basis between the interface of the mortar and the brick. Depends on the condition of the conditioning of the brick at the time of installation and whether the mortar was either too wet, too dry, or just about right. So depending on that will determine whether or not the cement paste actually will migrate into the brick. And if you get good migration, you get much, much less cracking. If the brick is too dry, the water and the cement paste will migrate, won't migrate appropriately, and you'll get cracking. And the same is true as if the brick is too wet, you won't get that migration of the cement to the interface of the brick. So what we're seeing here is a little bit of settlement, some cracking, it's cracked a brick. We've got some deterioration here. Very likely we've got some steel here. And so we're seeing a failure of the mortar, particularly at the line with the lintel. And on these offsets, they actually look, if you look at them quickly, they look pretty good. What they have done is they've taken sheet metal and covered up these very, very deteriorated steel lintels. So there's been a lot of water getting in through the system into the brick. And this is one way that they've tried to deal with that particular problem, although it didn't solve anything other than to make it look prettier. So we've gone into a little bit of the visual examination. In this particular case, we moved into water testing. Wanted to verify why the water is coming in and how is it coming in. And a visual won't always tell you, as I indicated with the windows, could it be water coming in as a result of improper flashings or no flashing, or can it be a condensation issue? So in this particular case, moved to water testing of certain components in order to make a determination of what the problem is. Now, this type of testing, in order to verify it, may require making some openings, which was done on this particular job. Now, in the water testing, there are test procedures that you should be following. However, these test procedures are usually used for particularly the 503 for newly installed storefronts. Okay, there is a methodology, and it involves a time frame for running the water on to make sure that the flashing systems are working appropriately. When you get into the investigative methodology, you don't have to follow a time frame, because what you're looking to do in an investigation is the water coming in at the locations where it's being seen from the inside. So we don't really care about, testing it for 15 minutes, because in some cases, testing it for 15 minutes might mean we're flooding the building. So we want to be able to duplicate what's happened, but do it appropriately so we're not affecting interior operations. So these are used as the standard for how we test, but it does get modified based on the circumstances under which we're testing. So there are two major, where there are several methodologies that are involved. The easiest one is a calibrated nozzle. You are typically running a certain pressure through that nozzle that you can control, and you're also setting that nozzle at a certain distance, usually about 12 inches. And so you have these nozzle systems that actually have a rod attached to them that'll make sure that you're maintaining the distance. Now, you can have where it's tested with or without pressure on that component that you're testing. A lot of times in investigation, we're running a static test. We're not going to put negative pressure on the interior space in order to try and duplicate, let's say, hurricane force or high wind events. So it depends, and it's also dependent upon cost too. Do you really need to do that? A lot of times we can get our answers either with the nozzle test, or we can get it with a spray rack, where we're putting a uniform, essentially a uniform amount of water on the entire component in order to test it. So there's different ways you can approach these systems. Now, on the protocols that were used on this particular building, it was mainly using a spray rack that's set up against the windows, and then making selected openings in these interior spaces in order to see if the water is coming in. Because sometimes when you have sheetrock, particularly you have sheetrock ceilings and walls, being able to see water coming in immediately may not happen. You may need to add a significant amount of water before it starts showing up through the sheetrock. And then with the sheetrock in place, we don't really know where the water is entering through that wall system or that window system. So typically you're looking at making selected openings through it. And here you can see the the rack is set up over a window system and then running it. Again, this is a pressurized system, and you may need pumps in order, as you get higher up on a building, in order to get the pressures that you need in order to run this. And in this case, we can see, one, that we've had deteriorated wood as a result of water infiltration, and the testing revealed that we were able to duplicate where that water is coming in and causing this particular damage in this particular room. Again, you can see we have stained plywood on both surfaces, the horizontal and the vertical surfaces. And then the windows, again, this is where we're looking for, is it a window problem or do we think we have a flashing problem? And so typically on something like this, we would do a combination. We may want to get water only on those windows, so we would adjust our nozzles appropriately. Or if we want to get the lintel, we may use this system, or we may use just a handheld nozzle system to test the through-wall flashings. A lot of it depends on whether or not we're going to be able to get enough water on a particular component in order to replicate the leaks that are occurring in the building. In this case, the spray rack system worked quite well in answering the vast majority of our problems. Since we have a gutter that sits on top of the wall, the gutter is always suspect as to whether or not it's contributing to a particular problem. So in this particular instance, the downspouts were plugged and water was added. And you can see here that we have water that's actually running down the walls, which is a good thing, except you can see above us, the gutter's not full. So why is that happening? That then becomes the next question. And we'll get into that a little bit later and whether or not this is contributing. And what they found is that as they filled this up and it started leaking, they were replicating the leaks at certain locations within the building. As we can see here, as a result of filling the gutters, this is what we're getting on the inside of the facility at those test locations. Now, here is a cross-section of this particular interior gutter. It's a sheet metal gutter that they, at downspouts, they basically put a drain in, a drain body in that downspout, and that then goes in and discharges into the downspouts here. The problem is kind of twofold. If you look at the front and the back, you can see the gutter essentially is at the same level. In fact, very likely the water gets behind the gutter before it starts running over the front of the gutter. The second problem is there's no secondary flashings around here, and usually this is a pretty typical problem that we see when they're not paying attention to either the design or the construction of interior gutters. They fail to put this flashing in so that in the event that we have a leak, the water has a way, does not have a way to get into the interior spaces. So when this gutter overflows, which is not uncommon during heavy rain events, it's already past most flashings at this point. If it's getting back here, whereas it should be getting up here, which it's not, and so this is why a lot of the water was coming in those situations. Construction of the windows is also critical. In this particular case, what we're looking at is we actually have negative slope on the windowsill so that water, particularly during a wind-driven rain event, is actually able to penetrate failed caulking, which is not uncommon. That's just a maintenance issue, but it usually gets ignored. But it allows water to stand there, and if there's any defect in the flashing system or the caulk system, it then can come in. And this is one of the other problems that was encountered on this particular facility. You can see we have a negative slope on this. Also, we found that we were dealing with improper installation of the windows. They weren't, there is a process. You know, it's not just a matter of let's put it all together, drop it in. And, you know, usually with guys, the problem you encounter is that if all else fails, they'll read the instructions. So usually that doesn't happen in the field. They kind of the attitude, well, I've been installing windows for 20 years. I think I know what I'm doing. And a lot of times what we find with window installations is a failure to install the system in accordance with the manufacturer's instructions. Don't place a caulk in the right places. Don't place it at all. Puncture the framing at inappropriate locations, which then allows water to get in places where we don't want it to go. So this can be a problem, and in this particular facility, we were running into that. And then on this job, made openings to see how was the through wall system installed. And there were problems with the through wall system. We look at the upper photograph, we'll see that the through wall flashing does not extend all the way to the walls. There are no end dams here. So any water that hits this can either come in any defect or holes in the masonry, right in this area, the front edge of this, or it can travel sideways horizontally to the ends and then come in. And there may be nothing below that's going to catch it and kick it back out. Also a lack of weeps. Fine to put this in, but if there's, you know, everybody thinks, well, it get through the masonry. Well, it doesn't. It's got to have a weep system in order to let that water out of the cavity areas. Also, it's important during construction to keep the cavities clear of mortar. Failure to do so allows any water that does get in to bridge across to the interior wall, and as a result, that can be a source of water getting into the building. It's got its own little bridge to get there. So these were some of the problems that were encountered with this. This one doesn't come nearly far enough out. Typically, you want to seal this down to the surface so that if water does wick to the end, or this isn't all the way to the edge, it can't go back underneath it. And this one, it can do that very easily. So that's kind of what we're dealing with. The original complaint, we got peeling water wallpaper, and we've got water leaks. So is it the roof? Is it the walls? Is it the windows? What is it? So what we essentially found is that we had a number of problems that were all contributing to this. If you look at the windows were not installed correctly. The sill pans were defective. They didn't have end dams in it. Improper slope of the sills to make sure water does not flow towards the building, but should have been flowing away from it. The masonry through wall flashings we usually find this is a typical problem in brick veneer, and it's become worse since this last recession because we've lost a lot of that institutional knowledge. So that typically is a big problem with it. As a result, if you don't control that water, you've got uncontrolled flow, can rust out your lintels, can then leak into the facility, whichever the case may be. And then at grade, we had weep holes that were not, that were covered up and clogged up with the mulch that had been installed. Gutters, we talked about those, and they were improperly fabricated, installed, may have been improperly designed for all we know, but a little bit late in the game to hang anybody over any of this anyway. So how do you fix some of this? Well, you have relatively inexpensive, or you have very expensive solutions to dealing with it. Can you repair an interior gutter? Yes, you can. It may require that you pull out the flashing system, the sheet metal system, and redo it so that you can then get in a secondary system. This is the least invasive. of any solution, try and solve it without full destruction of the system. The one that always works best is get the gutter outside of the exterior wall. In this particular case, you can see we've got a little detail on that where closed up the interior gutter completely, put new sheet metal flashing over it, and the gutter and downspout system is now outside of the exterior wall. And you can see what that looks like. This is the finished product when they got done with this. And this solves your gutter problems. Doesn't look nearly as pretty, but from a technical engineering standpoint, works very well. Again, looking at the detail of a bigger blow up of that, they took the wood blocking, closed everything off where the gutter had been, and then moved it to the exterior of the wall. In some cases where the downspouts were inset into the existing wall, kept that look. Where the downspouts were actually built into the wall, did not. We put the downspouts on the exterior face of the wall. On the flashing issues, you know, this is kind of the bad news, where you're going to spend a lot of time and money trying to fix these particular problems. There's no real easy way to do them. Well, I take that back. You could put a coating system on. Clear coat, you could do that, but that system will fail usually within 3 to 5 years, and you'll be right back where you started. The whole intent of the coating is to keep the water from getting in there in the first place, but that clear coating will typically start cracking very quickly over the joints. You can do a more durable coating, such as a urethane. That's going to change the aesthetics of the building completely. So it's going to kind of look like a brick wall that's been painted. That will last longer. And where you have to be careful about doing something like that is depending on where you are in the country. The farther north you are, the more of a problem you can have with vapor migration from the interior to the exterior. It then condenses at the interface of the brick and the coating, freezes, and you start getting spalling of the brick face in certain circumstances. So it really depends on interior operations, what kind of humidity is run inside, whether or not that will be an issue. The farther south you are, the less that will be of an issue. And it is a cheap way, but you get to do it over again, usually within 8 to 10 years. The third option is where you go in and you start removing brick, and in this case, lintels and windows. We had no choice but to remove the windows because they were installed incorrectly in the first place. So they were going to have to be removed. But this entails removal of brick materials above, replacement of the lintels, put in new through-wall flashing systems in there, and then installing new brick. And the problem you have with this a lot of times is that technically it'll work very well if you get it done correctly by somebody that actually knows what they're doing. The problem you can run into is whether or not you can get the matching brick. A lot of times now we can, because the firing of the brick is fairly standardized because they're using gas in order to control the heat within the kilns. And so we've had a lot of success with brick replacement. Unless it's a brick that's just no longer being fabricated at all, then it becomes another problem. And you can see some of the detail work that was done on this particular one. So below the windows required, in some cases, a complete reconstruction of the sills. 1, to get the positive slope. 2, to get rid of the rotted wood. Reset the sills, put in new flashings in order to make sure that the water does not get inside the building at these locations. So these are some of the details that were developed in order to deal with this. You can see during construction what this is looking like. in order to make sure that we don't have water coming in. And then the finished look. As you can see now, this is the architect's nightmare, putting up gutters and downspouts on the exterior face of the building. We're not quite finished here. They haven't made the connections of the downspouts to the underground drainage. The wall work is pretty much done. You can see a little bit of a difference, but age will usually take care of that over time, where you'll hardly notice the difference. And if they've done a good match of the mortar to the existing, in a few years, you really won't tell the difference. So the interior conditions, okay. Once you get done with the, here's what we had on the original problems. Reconstruction essentially is to tear all of this out, rebuild it once the windows and the window flashings have been reconfigured, redesigned, and reinstalled. So this is what you will get. And as far as we know, we haven't had any problems with any of these problems that were detected within this particular clinic. So turned out quite well. Part of what also had to be done was to deal with trees. I know we love trees, but trees are not the friends of roofs and facade systems in all instances. So some trimming was required in order to deal with some of these issues. A little bit of modification had to be done to the underground drainage system because we're now putting the downspouts on the exterior wall. So a little bit of digging in order to redo the drainage underground. And then that's the completed look. You can see that we have a little bit of differences in color, but actually it matched up fairly well on the building. And, you know, believe it or not, the downspouts actually give a little bit of framing to the window systems on some of these walls. And that concludes the presentation. I hope what has been presented will give you a pretty good idea of what it takes sometimes in order to evaluate a particular problem, because there's a lot of times we get involved with projects where you have a lot of finger pointing. Hey, it's a roof, it's the HVAC units, it's the walls, it's the windows, it's various different things. And it requires a methodology in order to try and figure it out. And usually with that methodology, there's a cost associated with it. But if you do it right, the cost can be controlled. And it's going to save you a lot of headache in the long term, particularly the cost of having to replace materials again and again and not getting the solution right. So the methodology is very important. Right now we're showing Richard Perkins as the point of contact. He was the last one to give this presentation a couple of months ago. So you can call Richard if you want. You can call me. My email address essentially is ray.ramos@raymondllc.com. And our phone number is 770-483-9592. So if you have any questions, feel free to post them on the chat, and Michael will get that to me because in that particular instance, I'm technologically challenged.
So again, this is Mike Ramos. If you have any questions, I can unmute you at this time, or you can manually unmute. Or of course, if you have any questions that you'd like to submit via the chat, we do have this time available to have further discussion.
And, you know, we can open it up to, you know, what keeps you up at night and dealing with your buildings, particularly as it pertains to water intrusion. We don't have to talk about this particular problem and our solutions. We can talk about your problems. Also, if you would like, you can send us an email. Hey, I've got this particular problem. we can take a look at it at no cost to you. We're not going to always solve your problems that way, but we can probably get you at least pointed in the right direction.
So we're not seeing any questions on our side. We do appreciate your time and joining us for this Lunch and Learn webinar that we offer through AIA. On that note, we do have your registration information for this webinar, and we will be sending out the continuing education units and those certificates in the next few days. If you have any questions about that, you can also email myself, Jessica Gugliotta, or Lynn Beeman.
Okay. Thank you very much. It was a pleasure doing this, and feel free to contact us if you have any questions or would like to discuss particular issues associated with your projects. Thank you very much.
Thank you, everyone. Signing off.